You guys behave. If you guys don't interrupt me at all, we'll probably do the next lesson tomorrow. Okay. The next lesson tomorrow is about rates, proportions, percentages, and ratios. That's the one for tomorrow. Okay. So, you guys have heard about infinity, right? Infinity? Okay. Infinity is just another way of saying something is endless and continuous and it never stops, okay? So again, it's not saying something's big, it's not saying something's huge, it's saying something is endless and keeps going on, okay? For example, if I were to draw a x and y axis, you guys have seen a line graph before, right? If I were to draw my line graph like this, is my line graph infinite or finite? Infinite. Why is it infinite? Okay. Anyone? Sophia? You can say it. It's fine.
I'm scared.
No, don't be scared.
Um, the arrows.
The arrows, okay? The arrows tell me that this graph is going to keep going on forever and ever. Now, there are two types of infinities when it comes to math. There's something called positive infinity and something called negative infinity. Can you guys tell me what you think positive infinity has to do with? The positive or the negative numbers? Gabe.
I think positive infinity is like something that's infinitely positive, but keeps on going up, and then negative infinity is something that keeps on going down.
Yep. Goes up, and negative infinity goes down. Okay, perfect. You guys are going to get to learn about this later on. I'm just going to introduce it to you. So, for example, if I look at the right side of the graph, so this side over here, my graph is heading towards positive infinity. If I look at the left side of the graph, which is the one going down, which way is it going? Towards what infinity? Positive or negative? Negative infinity. Okay. So I can ask you guys if I really wanted to on like a quiz. I'll be able to look at the left side of the graph, to what infinity is it going to? Positive or negative? Have you guys ever seen a U-shaped graph before? A parabola? No, you guys have never seen a parabola, or as you guys will probably call it, a parabola. Okay, you guys have probably seen it. Maybe. If your grade 8 teachers taught you, we'll see. So, if I look at this graph, if I look at both sides of the graph, to which infinity is it going to? If it's going up and continues to go up, what infinity is it going to? Positive. So the y's are going to positive infinity. Okay. If it's going down, that means the y values would be going to negative infinity. So just get used to the notation where you see positive infinity and negative infinity, okay? The only way something doesn't go to positive infinity or negative infinity is if I have dots at the end of the graph. That means the graph stops there. So some examples of things that are infinite or have an infinite amount are the natural numbers. It never ends. So 1, 2, 3, 4, 5, 6, 7, 8, all the way to positive infinity. Decimals can be an infinite number. What decimals can be infinite? Aaron. Pi. What else? What else? How about repeated decimals? They can be infinite all the time. So 0.33333333, they keep repeating. So we can also write it as 0.3 with the bar on top. And same with the line, like I said, if you have points here, this is not infinite. The only way it's infinite is if you have the arrows at the end. Okay, so just keep in mind when you're doing stuff with lines later on. Yes, Natalia? This U graph?
Yeah, we said that both of them are positive infinity.
Yeah, because look at the arrows. Where are they pointing?
Yeah, but on the like
X-axis?
yeah, on the x-axis, like the right side would be going positive.
Yeah, so that's what I said.
The left
So look
side
at the
would be negative.
look at what I wrote. What did my sentence specifically just state? You need glasses? I was just talking about the y values.
Oh, okay.
But you're right. The right side of the graph, the x's go to positive. The left side of the graph, the x's go to negative infinity. The below part,
Yeah, the left down.
like this part over here,
Yeah.
this one doesn't exist in this graph. So just my y values always go to positive infinity for this one. But you're right, Athalia. If I'm talking about the x-axis and I talk about the right side of the x-axis, you would say positive infinity. And for the left side of the x-axis, it's negative infinity. So I'll just write that down as well. So that would be positive infinity. And then the left side is considered to be negative infinity. Okay, so be sure you can copy that down. I hate this lesson right here because everything's so many words and I can't, you guys, I don't want it being so small.
Facts.
Because I'm a teacher.
Oh,
So,
oh, and you're connected right to it?
no, I think someone said actually I had an Ethernet cord. I do not have an Ethernet cord. No. I would love an Ethernet cord. That way you have a stable connection all the time instead of relying on. Do we even have a router? Yeah, right there. I have a router. Hello. Okay, so make sure you're copying this down. I'm just going to take attendance. To zoom in, or is that, or can you guys read that? Zoom in?
Setting up Rick.
I don't know how much I can zoom in without you not reading anything.
If you come up to
So your test will probably be, if we don't do the lesson today, it'll probably be Tuesday.
my what?
Your test for this unit.
Okay.
Oh, did you guys sign your quizzes? I'll check after.
Okay, can I do it tomorrow?
About
Sir, can I do it tomorrow? I forgot about
I'm the same one as you.
If you don't bring it tomorrow, I'm calling home.
Okay.
So Athalia posed a question. Sorry, I had my mic muted. So the fraction 1/3 is finite because it's an integer over an integer. But once you convert that value into a decimal, it becomes an infinite decimal because the 3 keeps getting repeated over and over and over again. Yes, Sophia.
No, nothing. I was just gonna ask the question that I just about like
Oh.
finite just means that it's not.
Yep. So this is finite since it's a fraction. And 0.33 is infinite because the decimal never ends. Okay, so I'm going to keep that there. Okay, we're not going to be talking about limits in calculus. So if you guys ever take calculus, you guys are going to learn about this nonsense over here. Yep, I think that's what your sister's doing right now, Cal. Is she? Yeah. It's called the first principles.
I don't understand.
It's called you doing the derivative the long way and then hating me as a teacher when I teach you the short way. So I'm not going to be talking about this type of limit, so don't worry about this. This is for grade 12. We're just going to be using limits as a practicality. So when you guys think about limits, what examples in the real world have limits to it? Think about like rides, elevators, school capacity. Pardon? Huh? Humans have a limit to what?
Okay, ready guys?
No.
Oh,
Sophia, do you have an example? Do roller coasters have a limit?
I know, I want to do it.
Yeah, they do.
Yep.
Ferris wheels.
Roller coasters have a limit. You have to be this tall, or it can only hold a certain number of people. What else has a limit?
Ferris wheels.
This game.
Pardon?
Ferris wheels.
Ferris wheels?
cars.
Cars?
The speed of cars. Yep. The speed of cars.
Why does it have a word?
Oh,
What else has a limit? Give me one more. One more. Guys, one more example that something that has a limit. Nick?
Speed of light.
Speed of light. Sure. Because it has a number to it. Speed of light. So a limit is something that reaches a certain height or speed or capacity, either a high point or a very low point. That is what a limit is, and that's how we're going to use it practically in this math. And limits have a lot of practicality because for some of you who live in a condo or a building, if you go into an elevator and read the actual thing that has the buttons, it always says there's a limit of like 14 people or like 2,000 pounds. Okay. And when I was a kid and like a bunch of people get in the elevator, I'm like, holy crap, we're gonna get stuck because we're over like the limit. Yeah, I get scared. My biggest fear is probably, besides height, is getting stuck in an elevator. I don't know why. So yeah, so there's a limit to the speed of a car. In a speedometer in your parents' car, what's the maximum that it usually goes to? No.
240.
240, 220. But does the car actually reach 240 and 220?
Yes.
No.
My Toyota Corolla, it says 220, it doesn't even reach 220. It depends on the horsepower of your car and how powerful your engine is.
Hold on, isn't there like meters on most cars?
There is limits.
Like, I don't know about Toyota, but I know like my brother's car. It says like 240 at the end. And it can reach 240, but I have to look at like 180 or something.
Yeah, mine doesn't reach. I think mine goes, I think 180 is the fastest I've gone. So yeah, doesn't go over that. So a limit is a prediction as well of something we didn't observe. How do we make a prediction? So we just basically guess using the information given so that we can predict what's going to happen. Sophia, turn around, por favor.
I'm turning.
Thank you.
Placing against the wall.
Okay. So an example of a limit would be this. So pretend you're watching a soccer game when you're watching like our crappy Wi-Fi here and we have a buffering period, or when you're watching a movie online on those, those websites that you're not supposed to stream movies off of, and you get a buffering period. So for example, at 3:58, the white soccer player has a ball. At 3:59, he shoots the ball. Then at 4 minutes, we don't know what the hell goes on. And at 4:01, the ball is magically near the goalpost. And at 4:02, the ball makes it into the net. So what do you think? What would your prediction be for the ball's prediction at this missing point in time? Where would the ball be? So remember, the ball is here at 3:59.
We love the net.
But the net's here. So where would it be? Gabe.
Wait, what if I say one
So remember, at 3:59, the ball is near the goalie. And at 4:01, the ball is about to go in the net. So where would the ball be at 4 minutes? Gabe?
It would either be in the middle of the field
Mhm.
or still in the net.
But it's in the net at 4:02. It can't be in the net at
I don't know, but because after they score a goal, you gotta like celebrate and like the other teams like they're crying and then again you're like celebrating like some good minute.
Anyone else have an answer? Yeah, the ball is right here, the red circle. At 4 minutes, we don't know what happened, and at 4:01, the ball is near the goalpost. So you're saying the ball's over here?
No, he kicked the ball. The goalie fell.
He shot it, the player nutmegged him, and went down.
What's not my tip?
Yeah. So what Kobe was saying is the goalie slid, woo, and then the ball is right here. And then at 4:01, the ball got closer, and at 4:02, yeah. So ball went through goalie's legs.
How does it feel like that?
Because it's about a limit and trying to predict something that's going to happen.
It's called a regular net. You don't really say, yeah, you say, oh, I read someone.
It takes less than a
What's the
second.
difference?
It takes less
All
than a
those
second
Okay, but you're.
for all of this to happen. It's not 4, 5 seconds.
Anyways,
So why is it 4?
how's the
No,
weather?
that play probably takes 4 seconds to happen. Yeah, it does. I can try it on you. Let's go outside.
What does this have to do with infinite and finite
We're not talking about infinite and finite anymore. We're talking about limits now.
limits?
Yeah.
So what is this limit?
So limits. So there's a limit on terms of like how high something can go or how low it can go. but there's also a limit in terms of like if there's a missing piece in something, you can actually predict based off the information you have before and after what could have occurred in the middle.
But not
So are you gonna ask us like this?
Steven, ball went to the left.
Not that. I'm gonna ask you like practical questions, like say if to predict something. Like for example, if the capacity, what would the capacity or limit be of an elevator? You'd be like usually like 20 people or like however many pounds, that type of thing. Or if I give you a pattern, another example. So let's just say I give you a pattern. I give you like the numbers 7.2, 7.1, 7.02. 7.01, 7.001. What would the limit of this pattern be? Basically, what would the number that it's approaching going to be?
7.999.
What is this pattern getting closer to? What number? Nick?
Infinite.
No.
Oh,
Lauren? 7.
Oh, physics. I thought I didn't see the test.
how?
7.2, 7.1, 7.02, 7.01, 7.001, 7.0001. It's just telling you that it's getting closer and closer and closer to 7. So that would be the limit for that pattern. Just like when you're driving a car and it's trying to reach 180 and it's like hovering between 179 and 180, that means the limit of the speed of your car is 180. I wouldn't suggest you try that in real life because I don't want you guys getting speeding tickets, so don't do that.
The only problem.
Unless you want a ticket, then that's on you. And the last thing we're going to be talking about is going to be number density. Have you guys ever heard about number density? No. So let me know when I can move down. So, because I know some of you are copying and stuff. So.
And your mom.
No, I didn't. No, but he didn't hear. He didn't hear.
I heard.
What? No, you
I
didn't.
did.
How are you gonna tell them what you did or didn't?
Because I heard it first.
So that means you just admitted to me that you heard it.
You guys suck. A police? I want to be a police.
Okay, guys, Atalia has a question. I need to hear the question, please and thank you.
What note do I take for limit?
Yep.
Okay.
Okay.
Like what's the like in volleyball, Atalia? What's the limit about the highest you can jump?
20.
Inches? Inches?
Inches?
Yep.
Okay.
For those of you who work out, what's your limit for lifting something? You guys have a limit. You guys, if you exceed it, you guys are gonna hurt yourself. Risen. See, that's your limit. If you go any higher, it becomes more difficult, right? And you can hurt yourself. That's fine. Gabe, Gabe, you had an example? No? What's the limit of a mark in any? So this is what we call number density. This is mainly, the practical use for this would be in mainly construction or trying to build things. You guys know about like the fractions of an inch, the fractions of an inch, right? You guys know fractions of an inch?
Yeah.
What are examples of a fraction of an inch? Oh, we have no construction workers in this class.
Inches of cake.
No. How many of you have helped your parents like renovate something? Okay. You guys use inches or centimeters? Inches. Inches. When your dad says, give me 3/8 of an inch, or mom, that is a fraction of an inch. Okay? So number density has to do with exactly that. So the density property states that between two rational numbers, there is another rational number. So for example, if I'm trying to figure out what's between a half an inch and an eighth of an inch, I can figure that out. And that would be 1/16 of an inch. That would be the difference between both of them. So there are a couple ways to find rational numbers between two rational numbers. So the first thing to do is, in order to help you find that out, is to add both numbers together. And then the second step would be to divide by 2. So it's to find a rational number between two rational numbers. So for example, if I have the numbers 0 and 2, what is my first rational number between 0 and 2? 1. Okay. What is another rational number between 0 and 1? Yeah, or 1/2. What is another rational number between 1 and 2? So, or how would you say that as a fraction? As a fraction. As an improper fraction.
Oh. 3/2.
3/2. And then you can keep continuing to find rational numbers between 0 and 1/2, which is 1/4. Between 1/2 and 1, which I believe is 3/4. And then between 1 and 3/2, and 3/2 and 2. So for example, there is a rational number between 1 and 1/2. Yes, there is a rational number between 1 and 1/2, or 0 and 1/2, and that rational number is 1/4. So I have 0 over here and 1/2 over here. If I use my method to finding the next rational number in between those two, I'm going to take both numbers, add them together. So 0 plus 1/2, and I'm going to divide it by 2. So I got 1/2 over 2 over 1, and that is a complex fraction. So we would rewrite this as 1/2 divided by 2 over 1. And what do I do with my next fraction, or what do I do with the second fraction? Flip. So I got 1/2 times 1/2. And what would my rational number between 0 and 1/2 be? 1/4. So the rational number between 0 and 1/2 would be 1/4. And you can keep doing the same thing between 0 and 1/4 and 1/4 and 1/2, and you'd be able to find more examples of rational numbers between those two pairs of fractions. So for example, here we have between 0 and 1/4, we have 1/8. Between 1/4 and 1/2, we have 3/8. So if you really think about this, this is technically what a measuring tape looks like. Okay? If you want to find something between two different sets of fractions of inches, that's the way you would do it. So again, the practicality for this is mainly in construction or measuring stuff, or when it comes to architectural design and scales, like when you're drawing out sketches. And the question, how do we find a number between two rational numbers? It is a thing I already mentioned. We are going to step 1, add both numbers together. And the second step would be to divide by 2 after. to divide answer by 2. So finish copying this, and then that would be, yeah, that is basically it for today. Or should I do the next